Hello everyone, welcome back to this new video made by the academic officers at Warwick Economics Society. This is probably gonna be my last video for this series, and I hope you're enjoying them. And today we're going to talk about the power of test, which is a concept in EC124 stats techniques. This, in my opinion, is the most difficult concept in this module, and I suggest you to learn hypothesis testing and confidence interval first, and then watch this video. So I've also made the video on confidence interval, so I suggest you to watch that video first and then come back to watch this one. So let's start by defining what power means. Power is basically the probability of rejecting H naught given that H naught is false, or there's another way of interpreting this, which is basically a 1 minus the probability of a type 2 error. We're gonna see this in a graph, and I'm gonna give you the 3 simple steps to solve questions related to this kind of concept. So these are the 3 simple steps that you should know when solving a question related to power of a test. The first one is to know when to reject H naught. So you want to find a critical value at which you just reject H naught. And this is simply going to your statistical table and find the critical value. Obviously, you have to understand from the question first what kind of values that you want to reject. So, for example, if you have a two-sided case and the question asks for a 90% critical interval, you go to the table and then go to the 5% interval, and we will know that the value is 1.645 for a normal distribution case. And then you go to the second part, which is it gets more tricky here. You want to find the sample mean corresponding to critical value, and you have this formula here. So what we're trying to do is basically similar to what we did in the critical value in the confidence interval thing, and you want to find the 2 values at which you reject the null hypothesis. So yeah, these 2 values, and this is the critical value that you get from the first part, and you have here the standard error and here the mean, and this is the value that you want to find. And they will be 2. One is x1c and one is x2c, and they will be respectively here and here. And then the last part of this process is to calculate the actual power. So you want to have the values x1c and x2c, and you want to compare it to the true mean, which is mu1. Notice here, mu1 is the true mean, and the mu0 here is the sample mean that we're given. And yeah, we compare it to this thing, and we calculate the power, which is given by these 2 parts. Now I'm gonna show you in the next slide a diagram which depicts this concept. Here we have the power. What we basically have calculated are these 2 points. So this one here is the distribution with mu0, and this in purple is the distribution with the mean equals to mu1, which is the true value of the hypothesis. And what we're trying to calculate is basically this area delimited by this and this, because what we're doing is basically 1 minus type 2 error, and yeah, all that's left is what we have, which is the power. So now let's try and solve one question. So there's a question that says the sample mean equals to negative 0.1, and we have that the standard error equals to negative 0.01157. We also know that this follows a normal distribution, so you should use the normal distribution table for the critical values, and we are us to calculate the power of a test at the 5% significance level, given that the true mean mu1 equals to negative 0.08. I urge you to stop the video for a few moments and go through the question by yourself using these steps that I have given you. Okay, now let's try and solve this question. First part, the simplest one is to find the critical value at which you reject H0, and we know that it's normal distribution and we have the 5% significance level. So we go to the table, and we know that we also know that it's a two-sided thing, so we should go to the value for the 2.5% one, and we find that the critical values are 1.96, and this is part 1. Then part 2, we want to find the values, the actual values that you want to plot on the graph. So these two, x1c and x2c, and you do this by writing out this formula. So let's call it b minus the mu naught, which is 0.1, negative 0.1, divided by the standard error. Obviously I made this question simpler, so we focus on the on the steps, and then you equate this to plus minus your critical value, which is 1.96. And from this you'll find that you have two values, which are negative 0.123 and negative 0.77. No, negative 0.077. So some of the question we ask you to also draw the graph in the later part. So if it does so, I would suggest to stop at this stage and draw the graph first for this distribution. So wait, we draw a normal distribution here, and we know that the sample mean is equal to negative 0.1, and we found our two values, which are negative 0.123, which is more negative than negative 0.077. And yeah, so this is the first part of the graph with mu naught. Now so this is part 2 completed. Now let's move on to the third step, and here we want to compare our values that we found here to the true mean that we are given here. So what we are going to do is basically calculate the probability of x1 c bar is less than negative 0.123, given that the true value equals to negative 0.08, plus probability of x2c is greater than negative 0.077, given that beta equals to negative 0.08. And then we can write this out as p of t is less than negative 0.123 minus the true value over the standard error, which I'm not gonna write out, plus t is greater for this value. So negative 0.077 minus 0.08 all over the standard error. And we're going to find out that d is equal to negative 0.371 plus, this is t is greater than 0.233. And with these values, we go to our statistical tables again, to the normal distribution one, And we find that for this one, the probability is basically is 0. And for this one, we have we go to the closest one, which is 0.23, and we find that its value is 0.409, which means that we have 0.409 of power, and which translates to basically 40.9% of power. Okay, so that's it for power of test. And if you're asked to draw the diagram, let's go back to the previous part. We want to use a different color pen for the true value. So this is the true mean, and this is the sample, and we know that mu1 is equal to negative 0.08, so it's gonna be somewhere between these 2 points, something like this. Actually, negative 0.08. You want to draw a distribution, and and then if you extend these things, this is obviously outside of our true distribution, and this is gonna be here. And from the question, we know that from the left there we have 0%. So in fact, this should go somewhere, and this should not, the two graphs should not intersect. And from this side, we have 40%, which is all this area here. And yes, that's it for this question and for this concept of power of test. I hope your term 3 is going to be really productive, and good luck for the exam.